So your grades are posted for the last grading period. A lot of them were disappointments because we did not turn in our work. Um, so before we knock out today's lesson, let me get my life together. There we go. Um, Chromebooks. If it is not a class assignment, put them up. There's really no reason to have them out in this class. Pencil and paper, not Chromebooks. Um, your anti-hour needs to be done. If you haven't got them done, there's no excuse. Um, Most of y'all could have logged on at home. And the ones who couldn't, you have 6 periods to get it done. Because those grades are currently in for those assignments. Um, Also, if you are absent, there's literally, you can go to Mr. War or you can come to me if you need your work. If you do not come to us, there's nothing we can do. There is no more turning in work at the last minute. It is your responsibility to turn it in on time. If it is at the grading periods, if it is the first 4.5 weeks and you try to turn it in at the end of the 9 weeks, I will not accept it whatsoever. Because you have 4.5 weeks in that first grading period to get whatever done. And then you have another 4.5 weeks to the next one. Also, no food and drink. If there is food in those tables, which I have cleaned out, you will get wrote up. You're going to have assigned seats. So if you put it in there, I will know. And if it's not your class, it'll be the last 4 to 5 people who sit in that seat. If your paper is graded and is left around the room, you are getting points deducted. If you do not want your paper, there is a trash can. Shouldn't be in a table and it shouldn't be on the floor or left on the table. So, group work. If your partner is not doing their work, you need to write a note on a paper saying they are not doing it. Let me and Mr. War know, and they won't get credit. They'll have to do it themselves. That goes for group work, labs, whatever. That's what it is. You will be getting a new seat and chart. So whoever's sitting beside you, that is your partner. That's group A. Group B is the ones, if you are sitting at a table of 4, those will be the people you're working with. If you are not, then I'll explain that in due time. As right now, people working right next to you is your partner. Group A, Group B will be whoever table, and this will be done before Wednesday. So we are talking about waves and sounds, and we are going to knock this out. So Far out of the sea, the wind distributes the calm surface of the water. A ripple forms. As the wind continues to blow, the ripple grows into a powerful wave that can travel a great distance. Near the beach, the surface waits eagerly. They quickly paddle into deeper water to catch the momentous waves. The surfers enjoy the power of the nature as they ride the wave to shore. What are waves? How can they travel so far? Why are they why are some waves more powerful than others? In this section, you will explore the waves begin and how they move. So waves crashing on the beach shows tremendous energy waves can carry. So waves, so write this definition down. Mechanical waves. Make sure you write this definition down. So the different types of mechanical waves, you need to write not only the definition of the different three types of waves, or three, not four. I mean, three, not two. My bad. We can always fix. So make sure you write all three of these down and the different examples of the waves. You definitely have plenty of time to finish it. Let's see. So mechanical waves and non-mechanical waves. So mechanical waves are waves that need a medium. So these are like, how can I explain this? So these are like sound waves, water waves. Uh, these are the basic waves that you normally see or hear. Um, the non-waves are the waves that you definitely can't hear. And those are the electromagnetic type of waves. So they can, non-mechanical waves can travel through a vacuum, and mechanical waves can not. So this is talking about the longitudinal waves. Those when if you stretch out a spring toy and push and pull one end, you can produce a longitudinal wave. Um, you can use a slinky. You can use a spring um, that sometimes you can see attached to doors. Uh, some people have them attached to different equipment. Those springs will give longitudinal waves, transverse waves. Um, you can make a wave on a rope, and the wave moves from one end to the other. And the rope itself, however, moves up and down or from side to side. The wave moves the median at the right angles to the direction to which the waves are traveling are called transverse waves. So these are just examples. A fantastic video to explain. And it's
Waves transfer energy from one place to another. You should already know how to describe them in terms of frequency, wavelength, and amplitude, which we looked at in another video. In this video, we're going to look at two ways they can be classified. Waves are produced as a result of vibrations and can be classified as transverse or longitudinal. Whether they are transverse or longitudinal depends upon how the particles are made to vibrate as the energy passes. Let's look at longitudinal first. This is where the particles vibrate parallel to the direction in which the wave of energy is travelling. Notice that the ends of the slinky don't ever leave the hands holding them. It's only the energy that travels. The places where the coils or particles are bunched together are called compressions. Where they are furthest apart are called rarefactions. An example of longitudinal waves is sound. When a drum is struck, the drum skin vibrates, which causes the air particles next to it to vibrate. This causes the next air particle to vibrate, then the next, and so on until the vibration reaches the ear, causing the eardrum to vibrate. The vibrating air speeds away from the source, creating a sound wave. Let's look at another type of wave, transverse waves. The hand moves up and down, as does the slinky, but the wave itself moves from left to right. So the particles vibrate at 90 degrees to the direction that the energy is moving. We can simply think of it as, in longitudinal waves, the hand pulses horizontally, pushing and pulling. and the wave energy also moves horizontally, back and forward. Whereas in transverse waves, the hand moves up and down, but the wave energy still moves horizontally. Again, the ends of the slinky never leave the hands holding it, it's just the energy that moves along. Transverse waves are usually used to show the wavelength and amplitude. Pause the video and see if you can remember how to label the amplitude and wavelength on the diagram. Did you get them right? The waves on the surface of water are transverse waves. They make the water surface go up and down. All types of electromagnetic waves, like visible light, are also transverse waves. So, now you should be able to describe the differences between transverse waves and longitudinal waves. Remember, it is the energy and not the slinky itself that travels.
Write all this down. make sure you write the types of examples of electromagnetic waves, which are microwaves, and which means microwaves mean what comes out of your microwave, those type of waves, X-rays, ultraviolet waves, radio waves. And majority of these waves you cannot see, that's why. So make sure you write down these examples. Make sure you write all this part down.